This is Michael Carano with RBP Chemical Technology and chairman of IPC's Thought Leadership Program. This Thought Leadership Program is newly created just this year to bring up to our members and our industry in general various areas of expertise that our leaders can bring to the industry and on a variety of topics, including environmental topics, competition, innovation, technology, workforce development, pretty much any critical areas that are affecting the electronics industry and its growth for the future. So this is a very exciting program, and we are very pleased that we've been able to get 10 to 11 experts, if you will, that have significant amount of experience working in our industry and with various companies. And with me today is Savita Ganjigatti. She is working in the area of printed circuit board fabrication and design. And she's going to provide us some excellent insight into things like workforce development and potentially even circuit board design and technology. So welcome, Savita.
Yeah, thank you, Mike, for having me with you in this program. And also, I'm very happy to be part of TLP leadership program. And uh, just to introduce myself, my name is Savita Ganjigatti, and I'm Vice President Engineering for Sienna Ecad Technologies. Sienna Ecad Technologies is basically in PCB designing and manufacturing company. Our parent company is manufacturing. We have our headquartered in Atlanta, USA, and we have factories at different locations in US as well as in India. Yeah.
And I noticed too on your resume, you at one time worked for AT&S as well. What did you do for? That's one of the premier printed circuit board fabricators in the world. They've done a great job. What did you do there with AT&S?
Yeah, so we started in 1997 as PCB design, very small PCB design company, Ecad Technologies. And through acquisition, I was part of AT&S. AT&S has a factory here in India, Bangalore, very close to my place. And so 5 years I was part of AT&S through acquisition. So, but I was focused on design as I said, even then.
Oh, very good. Yeah, that's very good. So you got a wide background, and I think our members would find that of interest. So being part of this thought leadership program, again, it's very important to have our leaders, our thought leaders, identify trends and be able to communicate the consequences of those trends if we don't understand them and we're not able to, make good with some new programs or new ideas. So what's the one thing, as far as the future of the electronics industry is, what's the one thing that interests you most with respect to electronics manufacturing? And with that, what are you passionate about when it comes to electronics manufacturing?
Yeah. So, Mike, when I just completed my engineering and came out as a fresh electronics engineer, I had no clue. Okay, what is PCB designing? And I got opportunity in one of the electronics defense public sector where I started working on PCB designing.
Okay.
And I found it's very, very interesting because I never thought there is something called PCB designing in electronics industry. I used to think always manufacturing or testing or hardware design, like circuit design. That's one thing. But this is very, very interesting, and also being part of now service industry. I every day I see new designs coming and new technologies emerging in the market. Especially, I have handled more than 20,000 designs in last 30 years from 88 to till now. So even 72 layer boards or even higher thickness boards and high speed up to 400 gigabits of speed. And it's all, I feel very interested morning to get up and come to office because it's so much change is happening in electronics industry. And technology is growing. Like every day it is new technology.
And to bring that score that point that you see with the technology and the designs and the evolution, what are some of the challenges that other designers face, like yourself, to bring new designs, not just from the drawing board to the market, but also the importance of how to design for manufacturability. Can you comment on these challenges, particularly with ultra high density now, and like you said, higher layer counts, high speed transmission, new materials? All these things are becoming challenges, as well as the lead-free, environmental challenge. So, can you give us a little bit of how you would recommend to these younger designers and manufacturers, for that matter, how they can put all this together and be able to compete in the world stage?
When we talk about complexities, increased complexities, or the demand, okay, what market demands, okay, this needs extra training or cross-functional knowledge. See, many times I see PCB design engineer don't have clue about manufacturing. Okay, they think even 1 mil board can be done, or 1 mil spacing can be easily done. Okay, because in the screen you see the trace is so big, right? Component so big, but if you really see the minute SMT components like O1, O5, they are so small, but we see that as a big component. They think it's all big. Okay, they can't imagine how small is the component, how tiny is the signal trace width. And this is one thing they don't understand manufacturing aspects until any engineer understands cross functional requirements or demands. It's very difficult. They do the best design. So that is one challenge we see. But how to make it happen? I think that's what is the challenge now. And especially manufacturing team don't know about the design, so they think design is like black box. Okay, it's not. They can't understand it. So one is cross-functional knowledge, and second one is learning. Learning is very, very critical. Reading, and a lot of information is available now free in the internet. Okay, anybody can learn. There are so many courses available. I think that's how we can mitigate the challenges today's.
Well, you brought up some very good points, and related to design and manufacturability and the different aspects of the process where engineers and designers may not understand each other's concerns.
Yeah.
So, and I noticed too that one of your key hot buttons, if you will, is workforce development and training. So that's very important. So, if you were to design a system,
Yes.
and I want you to think, out of the box, how would you mitigate this difference, if you will, or the challenges between design and manufacturability? How can you get the designers and the fabricators or the engineers to understand where each other is coming from, and to make it so that we can design for manufacturability, and the manufacturing gets done in on time and with the highest reliability?
Yeah, right. See, one thing is when I was part of AT&S, that's where I came to know all these handheld devices and fabrication challenges and design challenges. So that gave a lot of information or knowledge to design such high-end designs, very complex designs. And this inter-team or cross-functional training. So today we had morning, we had training the hardware team. There was a bunch of engineers. So we trained them on PCB design process and manufacturing process, and what kind of challenges, the kind of questions they were shooting up. That was really like amazing. Okay,
Okay.
we could understand the gap. And other thing is, this is where I got real interest in IPC. I am part of IPC India team. It's last 10 years. So IPC, I got attracted towards IPC because so it's not only design. When we write CID exam, so it's not just design. Designers should know fabrication aspects and assembly aspects, test aspects. This is where we start thinking, engineers can thinking about other fields.
Okay. And so, being part of IPC too, how can the association with IPC help, particularly where standards and training and certification? I'm sure you have a unique view of that and how that all could be um, put together for anybody, whether it's a designer, fabricator, manufacturer, et cetera?
Yeah, that's very interesting question. So unless I was part of IPC team, okay, and as part of design technology leadership team, so I used to be focused on my company, my work. Okay, whole day is gone. But when I started interacting with other teams, other engineers, that too from different fields like manufacturing, fabrication, every engine I could get chance to meet everyone. Okay, so we could exchange ideas, and we started thinking, okay, how to reach more people, or how to create some common platform where everyone can talk about our problems. So that really created good platform. That's what I see as biggest advantage.
Well, very good. This has been very informative, Savita. So one final question, based on your experience and what you've just told us, what other thoughts or comments do you have, and did you like to share with respect to the our viewers and the and related to the electronics industry in general?
Yeah, what I would like to talk is about, see, especially when you see engineers completing electronics, there is a huge gap between academy and industry. Okay, and if it's showing that interest and start learning when they are studying, okay, study also becomes very interesting. So because they can correlate what they are going in what industry needs, and
Very good.
also, yeah, that's very very important thing, and they should take different fields in the electronics. Okay, and many I see, even though they're electronics engineers, they choose to be software engineers. It's their choice, but still there are a lot of interesting fields in electronics. I think that
Well, very good. That
right.
sounds very exciting, and I like that idea of the bridge between academia and obviously manufacturing. I think that's very important for our future.
Yes,
Well, Savita, this has been very informative, and also thank you again for your time.
thanks.
With the IPC Thought Leadership Program, this is Michael Carano.